Hey boys and girls, today we're going over Unit 4, Lesson 2, which is Function Notation and Evaluation. Before we get started, just make sure you write your name at the top, and let's begin. As I read the do now, it says, which of the following relations is not a function? Anytime I see that keyword not, I like to highlight it or box it out to remind myself I'm looking for what is not the answer. If something is a function, that means that none of the x values repeat. So if I'm looking for something that is not a function, that means I will see x values that repeat. All right, so as I look at all my answer choices, I'm just gonna go ahead and underline all my x values in choices A, B, C, and D. All right, I know that all of these are coordinates, x, y. So again, I know that x comes first, y comes second. So x would be that first value in every choice. All right, so here we go. Let's look through. I'm looking for x values that repeat because I want something that's not a function. 2, 3, 7, 5. All right, nothing was repeating there, so I know this is not the answer. Choice B, 0, 4, 6, 0. Uh-oh. I can see here that this x value of 0 is in my first coordinate, and this x value of 0 is in my last coordinate. So since they repeat, this would be the answer that is now making this relation. A relation is a list of values, okay? It's making this relation not a function. So explain your choice. It's going to be choice B because the x value 0 is repeating. All right. Cool. So far we've just been working with lists of values like x and y, looking somewhat like this. All right, today we're going to be working more with graphs and a little bit with plugging into functions. So as I look down here below towards the bottom half of the lesson, let me just slide this up here. It says vertical line test. We know a function cannot have repeating x values. All right, we just went over that in the do now. We said that if any of the x values are repeating, then it's not a function. So I want a function that has x values that do not repeat. The vertical line test is used to determine if a graph, if a graph is a function or not. If the vertical line touches the graph more than once, I would box that or highlight that. If the vertical line touches the graph more than once, then it is not, capital N-O-T, it is not going to be a function. All right, so I'm going to go through with you now these three graphs at the bottom, and I'm going to use the vertical line test to check if they're a function or not. So here I go. I'm going to draw a vertical line which is straight up and down. I can see I'm hitting the graph up top and down below. If I'm hitting it more than once, it is not a function. So this would not be a function. All right, let's look at number 2. Go ahead. I'm going to draw a vertical line. I can see I'm only hitting the graph one time. All right, I'm going to draw another line just to check. Maybe like right here. Again, I'm only hitting the graph one time. Since I am not hitting it more than once, this is a function. This is a function. All right, and then last but not least, here I go. I'm going to draw my vertical line. I can see I'm only hitting the graph one time. So far, this looks good. Let me draw another line just to check. Oh my gosh, I'm hitting it up top, in the middle, and down below. I'm not even hitting it twice. I'm hitting it 3 times. This is absolutely not a function. All right, so that's how you would use the vertical line test. Up top, let's just add that to our notes. A vertical line goes straight up and down. All right, nice. Let's go to the next page. All right, so it says function notation. Here we are. Equations can be written in a form called function notation. I'm going to highlight that because that's the goal of the notes right now. we can use this as a quick way to evaluate functions for a given input. An input would be an x value, all right? So instead of writing equations like y equals 2x minus 8, I can write it like this, f with an x in parentheses, and I'm going to say that equals 2x minus 8. And the way you would read this out loud, this is read as f of x. F of x. So I would say this is f of x equals 2x minus 8. All right. For every function, each value is used as each x value is used as an input to generate an output, which would be a y value. So I'm going to go ahead and highlight that as well. So I know that x is my input. It's the number that I'm plugging in. Input, plugging in. Y is my output. That's the number or my answer that I should be getting out. So as I look at the notes here, slide up a little bit, it says, example, evaluate the function f of x equals 3x plus 1 for f of 2. All right. Notice that our x was replaced with a 2. So instead of writing f of x, they're writing f of 2. All right. Therefore, we're going to substitute a 2 for each x in the function. So again, instead of writing f of x equals 3x plus 1, we're going to write f of 2 equals 3 times 2 plus 1. Again, wherever I see an x, I'm replacing it. I'm substituting that number 2 in instead. All right? When you type this into the calculator, 3 times 2 is 6, right? Plus 1. And then 6 plus 1 is 7. So this would have been our final answer. F of 2 equals 7. It says our input, our x value of 2, generates an output. It gives me an answer, a y value of 7. So since I know x and y are a coordinate point, I can write that answer, f of 2 equals 7, as a coordinate point of x, y. I'm going to say that this would be 2, 7. And I'm going to put it in parentheses like a coordinate point. Again, this would be x, y. All right. Now let's practice this function notation, these steps that we just went over on the side for the rest of today's lesson, all right? Because this is important. You see this a lot on the regents, and we want to make sure we have it down. All right. So it tells me in example 1, f of x equals x plus 7. I want to substitute in x equals 5. All right, so I'm going to solve this equation for my input value, x equals 5. So here we go. Anytime I see an x, I'm replacing it with the number 5. So here we go. Instead of writing x, I'm going to write 5. That's going to equal x. Well, I know that anytime I see an x, I should be replacing it with the number 5 plus 7. And now I'm ready to solve. F of 5 equals, well, 5 plus 7 is 12. So f of 5 equals 12. And then if I want to take this one step further and write it as an ordered pair, an xy coordinate, I would say that my x value is 5. That's what I plugged in. And then I know my y value is 12 because that's the number I'm getting out. All right, let's look at some of the questions on the next page here. All right, so as we look up here at example 2, it says given the function g of x equals 3x minus 8, we want to find all of those functions. All right, so here we go. Instead of using g of 1, okay, before I actually start the question, I want to write what the function is. Since the function is g, I know I want to use the g function here. So I'm going to write that down as my first step. G of x equals 3x minus 8. That's the g function, so this is the one I'm plugging into. Again, instead of writing g of x, they wrote g of 1. So that means wherever I see an x, I'm replacing it with the number 1. All right? And that's going to equal, instead of writing 3 times x, I'm going to write 3 times 1. because again, wherever I see the variable x, I am replacing it, I am substituting in the number 1. And then minus 8 just tails on at the end here. All right, let me grab my calculator here. So just like if you have the graphing calculator app on your phone, or if you have a graphing calculator at home, here we go. Okay, sorry, just trying to get this in a good spot. So I'm gonna literally type into my calculator what I'm writing here on the side. So I'm gonna do 3 parentheses 1 minus 8, and I'm gonna press enter. And I can see that my answer is negative 5. So now I know that g of 1 equals 5. So again, when x is 1, my y value is 5. And that's how you would solve a question like this. Let's do another one together here. All right, so again, I'm using that function g. Here's my g function. I'm going to write it down first. G of x equals 3x minus 8. This time, instead of writing g of x, they want me to write g of negative 3. Here I go, g of negative 3. All right, again, wherever I see an x, I am replacing it with that number negative 3. So instead of writing 3 times x, I'm going to write 3 times negative 3, because again, I am substituting that in, and then I add on the minus 8 again. Here I go, g of negative 3 is going to be, well, let's type it in our calculator and see. Let me write it, let me fit it right here for you. Okay, 3 times negative 3 minus 8. I'm typing it in exactly how I'm writing it on my paper. Press enter, and I can see that the answer is negative 17. So I know that when I have an x value of negative 3, my y value is negative 17. All right, let's do one more here. So again, wherever I see that g, that means I want the g function. So I'm going to write that down first. G of x equals 3x minus 8. Instead of using the variable x, I'm using the number 0. So wherever I see an x, I'm replacing it with the number 0. All right, and I'm going to do that all the way through. So instead of writing 3 times x, I'm going to write 3 times 0. Again, I bring down that minus 8. And then one more time, let me type this into my handy dandy calculator. So again, I'm going to do 3 times 0. Oops, didn't go. One more time, 3 times 0. And then minus 8, enter. And I can see that my answer is negative 8. So I know that when x is 0, g of 0, my y value, my output is negative 8. All right, before I leave you on your own to try the rest of this page here, I just want to make sure that I'm reinforcing with you. Anytime you substitute, you always use parentheses. If you don't use parentheses, you can easily make a mistake. So again, anytime I'm replacing or substituting in, I put parentheses around that number, okay? Let's do actually just 3, that first one together, and then I want you to definitely practice some on your own. All right, to make sure you guys are getting this too, instead of me just showing you all of them. So if we look at example 3, it says given the function f of x equals x squared minus x, we want to find these guys here. Again, I'm using the f function. Here it is. So I'm going to write that down to start. So I know that f of x equals x squared minus x. Again, instead of using the variable x, I'm replacing it with the number negative 4. So here we go, f of negative 4. Again, wherever I see an x, I am replacing it with negative 4. I'm plugging in an x here. I'm going to use parentheses. Again, minus. I'm using an x here, so I'm going to put parentheses around it. So I plugged in the first x that I saw, plugged in the second x that I saw, and now I'm ready to rock. So here we go. Whoop. Let me type in exactly what I'm seeing here, okay? So parenthesis, negative 4, close parenthesis, squared, minus parenthesis, negative 4, close it. If I press enter, I can see that the answer is 20, all right? So I know that when I have an input value of negative 4, I have an output value of positive 20. Now I want to show you what you would have got if you did not use parentheses. So if I had just typed in negative 4 squared, no parenthesis, right? And then I just did minus negative 4, okay? Pretend I have no parentheses. I forgot to use them. When I press enter, do you see how I'm getting a completely different answer? This is incorrect. Okay, the correct answer was positive 20. So again, just be very careful. Anytime you're plugging in, you've got to use those parentheses. I'm gonna just set you up with the next guy, and then I want you to practice the rest of these on your own, and then you can check back at the end of the video for those answers. All right, so one more. Here we go. The function I'm using is f, so I want to copy this down as my first step. F of x equals x squared minus x. Again, instead of using the variable x, I'm replacing it with negative 1. So again, wherever I see an x, I'm replacing it with that number negative 1. I'm even putting parentheses around it from the start, so that means I should be putting parentheses around it the entire way through. So negative 1 squared minus negative 1. Because anytime I'm plugging in, I have to use parentheses. Again, I'm plugging in, I have to use parentheses. All right, I want you guys to finish this one on your own and then finish all the other questions. Once you are done, please check back for the answers at the end. All right, here we go. So for f of negative 1, you should have got a positive 2. And again, f of 7 equals 42. All right, make sure you're showing all of your work just like I am in the video. Let's look at the bottom 3 here. All right, so for example 4, I was using the h function, right? So the first step, copy the function over. I did that on all 3. And then again, I'm replacing b with whatever that input value, that x value was. And I'm always using parentheses as I plug in. So h of negative 3 equals 34, h of 0 equals 1, and h of 2 equals 9. All right, and then I'm gonna go to the back. If I'm going too quick, you can always pause the video. Let's go to number 5 here. So again, number 5 is using the h function. So the first step was I'm gonna copy over the h of x function, which was 3x squared plus 7. And then I'm just plugging in all the way through. H of negative 4 is 55. H of negative 2 is 19. H of 0 equals 7. And then last but not least, number 6, I'm using the j function. So j of x equals 2 minus 4x. Again, I'm copying it over, plugging in, and then typing it into the calculator to get my answer. J of 5 equals negative 18. J of negative 4 equals 18. And j of negative 2 equals 10. All right. Make sure you are working on the closure. That question on the bottom, it's got to be done to get full credit for this lesson. Or make sure you are showing your work, all right, as you're solving through. And then last but not least is the homework, right? That's always the last page. So make sure that you guys are working on all of these questions, all right? When you get to the bottom, make sure you are plugging in and showing every step, just like we did in the notes. All right, have a great day, guys.